first one will be John Yoon from Mercy College, and he's going to talk to you about secure data transmission over smartphones. And then please make sure that you continue to tune in, because at 2 o'clock we have Nasir Miman from New York University, who will talk to you about dictionary attacks on biometric systems. When John's finished, we'll take a short break, and I'll be back on before we begin the second briefing. Just a few administrative things. All participants are muted. If you have a question, at the bottom of your screen there is a little box that says Q&A. Please feel free to insert your question there. It'll be at John's discretion whether he wants to answer questions throughout or have you hold them to the end. I'll let him decide that. Either way, if you have any other questions CAE related, just plop those into the chat to me and I will answer them if necessary. Thanks.
Now, this is John Yoon from Mercy College. Mercy College has cybersecurity programs in 3 cities. I'm in the Dobbsbury and Manhattan, and also we have a Bronx campus. Today I'm going to share with you about secure and intelligent smartphone apps. Let's first consider the situation. Mobile devices, as you may know, is the emerging user interface to the databases. So there may be more attackers are considering to attack mobile devices. So how can we protect our mobile devices? Not only devices, but the data that we have or apps. Smartphone apps are portable. So you can carry, for example, air tickets all the way along your journey. You may not sure that your tickets on your apps are securely stored there. Some cases here in New York area, if you have the train tickets, then train tickets can be available on your smartphones. It's portable, so very handy, but at the same time, at the MTA server, Metropolitan train server, do not want you to share your tickets with anyone else but yours only. But apps may be portable, or sometimes you may change your cell phone from one to another. So how can the back-end server manage the tickets? So authentication or authorizations are always the issue. Some cases, data transmission is also a big issue. Some of the operations on your mobile devices is not just a simple one-time transactions. Maybe that is a long duration transactions. Many cases, right? You can start from your mobile device and waiting for some response from somewhere, and then you can repost it to some other devices. So all those things can be done on your smartphone. Smartphone becomes powerful, but at the same time, we have to make sure that it is secured. So that we consider in this talk authentication and authorizations. Can we do that not only on your local device, but how can we control it from remote servers? Some of the apps as well. One of the weakest the factor on your mobile devices is that there is no enough space that you can save your logging, log all the transactions, right? Something happens, then in cybersecurity, we always start from the log files in the regular platforms. But that's not the case in our mobile devices. Is there any way that we can post the logs to the back-end servers and then they can do something to your cell phones? So those are the issues that we have been considered. So this slide explains we have get the point. Okay, here. So we have cell devices and back end where there is a databases in the middle web servers. Okay, that's a typical way that you can post data to the uh, the back end database, and then you can bring it back, right? So data can be stored partly in local database and mainly the remote databases. Usually, data can be uh, transmitted in the form of JSON. All right. Um, so we need to make sure that if that's JSON, if there is any sensitive data in the JSON format, how can we make sure that we receive all the data that's sent out from the cloud databases, or vice versa? All right. So as part of the concept proving, um, we have a prototype. As you can see here, this is kind of the engine, the framework that you can, by entering your credentials, and sometimes you may have administration privileges, or sometimes your login is not allowed. Still, you may pick up some subject uh, to start. For example, if you are allowed to uh, take a Python class, the class that this app provides is not typical way, but it is a question-driven concept learning. What it means is that typically, if students wants to learn Python, then they can start with the textbook. First understand some concept, and then practice, and then finally they can do they can take some test, right? So but until that time, they do not know which one they know, which one they do not understand, right? Um, in this app, we first ask questions. Of course, there are multiple different levels of questions, so different ways the questions are selected to ask. Um, so at the back end database, there's some intelligent components so that choose the questions to send uh, to the local device and then question it. There is some time clicking and then questions and then some of the selections they can choose, and then they can see quickly if it is correct or wrong. Um, the students wants to take more questions, click this button, or students wants to learn a little more about this question from a video or web. So the possible uh, these are the prototypes that we currently do. So selecting questions are randomized, but not purely random selections. But there is some way of selections that I can share with you in the following slides. User performance can be posted on the back and the databases, and then there may be some of the analytics possible. So for example, initially the questions are from chapter one. There are different levels of difficulty levels, so that uh, each questions, each being here, there may be multiple questions. So questions are selected mainly more frequently from A to B, A to C in the chapter one. And then there's slightly more challenging questions from the next chapter. Uh, and then if that is successfully done, then when it comes to chapter two, then mostly from the chapter two and very hard question from chapter one, they're all the same priorities, same frequency of selections. And then a little bit easy courses, easy questions from chapter one and very easy questions from chapter three. So these are the pool uh, for the question selections. So this goes further and further, okay, in this way. So along that scenario, we checked the access control. Typically, user credentials can be stored on local database. Almost all the smartphone has a very light weight database, which is called SQLite 3. So it can be stored there, but mainly back-end remote databases. So once the user is allowed in the system, then depending upon user credentials, because we have multiple different subjects to provide, so so different level of authorizations, right? Some students may access applications 1 to 3, the other maybe 2 to 4. So each one has different applications, which means different subjects and a different level of questions. How can we control? If you are familiar with Swift in Xcode, then you can simply control it. First of all, interface builder. There's a graphical user interface, right? So button can be controlled. So if ID passed, then that particular button is clickable, otherwise it's not clickable. So we can manipulate that way. So it starts from, this is my cell phone. I'm going to give you the real demo if possible today. So this is app and it started, this is the first user interface. Then we have login and password and the role. Sometimes if you do not put any of these, still possible to do one simple subject, which is arithmetic calculation, by the way. If you could, if you login and password available, then maybe different subjects, okay? If you put the administration role also, then you can do some of the administrative works, right? So student management may be possible if you are a class teacher. So you can add or delete your students, or you can see students' performance, and also as a user enter proper login and password, then the students can see the list of authorized classes. And then by clicking this self access, so that they can answer questions from there. And then report on the back end. Every the question answering, that I mean, with the time elapsed, uh, are posted on the back end. So a lot of the data transactions back and forth. Okay. So at the back end databases, there is some analysis possible. So class performance can be analyzed, particularly in this case, there's a question driven learning. So for each question, each class may be able to see, oh, our class are very good, this type of question, but very weak, another type of questions. Therefore, teacher can focus more on that weakest points to fix it. Okay, so this is one possible way. If students do not have anything, then they can do arithmetic calculation. Some students can do arithmetic calc and Python. Some other guys can do even more. Okay, so different selections possible. Once questions are asked, then if students wants to learn more from video lecture, then by clicking this, then they can see some of the options to click. If this is clicked, then go to the YouTube to learn more. Similarly, they can do the web-based. If he wants to see some of the lecture, then that is also possible on your cell phones. So you will see the demo. Okay. This is one portion, the access control. As you can see in this scenario, there are so frequent data sharing between your cell phone or mobile phone devices and the back-end databases. Of course, they are all transmitted in this JSON. So JSON usually encrypted. Okay. This frequent sharing, or if there is a big data to be shared, you may not want to any data spoofing in the middle, right? So what we could do, if this is a data set, then depending upon the data sensitivity, we decompose into multiple JSON. So from this web server, send out JSON1 with the hash code to the server. All right. Of course, at the very first time, they shared the keys so that with the key, when this guy said and generates this web server as the key, so with the key and JSON1, so get the hash code and then send out the hash code and then JSON1. When this local mobile device receives hash code and JSON1, then so with the JSON1 and the key locally available, and then create a hash code, and then compare the locally generated hash code with the hash code received from the web server. If they are the same, then the data this guy received is there is no the integrity issues. Okay, so this type of things is continuous. This guy also if send out the acknowledgement, then with the hash code currently generated, and then ACK, and then generate a new hash code. So when this guy send out another JSON, then together with the the local hash code back to the server. Then server can also check to generate locally uh, to see if it is identical with the hash code received. This continues. All right. So that is the quick overview of the work that we have been doing. So the concluding remarks. So secure mobile apps can be implemented. Authentication and authorizations are controlled not only locally but also remotely. Therefore, remote server can at least um, see what's going on in the multiple local mobile phones, and also data can be transmitted uh, securely. The implementation that we uh, have been doing here, there's a cybersecurity class apps. Uh, as you see, there is a question-driven student learning, and also the back-end database server makes some um, big data analytics, and then that can be provided to students or class teachers. So this is a new learning methods. Uh, so this is mainly the concepts, and what I'm going to do is I'm going to this is the X code. Let's see if I can share. Can I share, Jill? Can I share my cell phone or desktop only? Currently, that is.
Desktop only,
Okay.
unfortunately.
Then I'm going to disconnect my cell, and I'm going to let's do here iPhone XS. I'm going to give a demo only on this phone emulator. Okay. So all right. Let's say initially I didn't do anything, then still I can do arithmetic calc. Okay, arithmetic calc is if we click this arithmetic calc, okay, and self access, then this is very simple. And also it is, but it's automatic random generations. This is a simple question so that I can answer, right? What is this? 11.4. Hopefully that works. Oh, that's correct. We can do more, uh, and it goes up to our backend database. And also, if we do, for example, fill and then login, then this guy can do arithmetic, calc, and Java, right? Or if I do John and J Yunin, then I may be able to do more than that, right? So I can do more. So let's do Python and go to. Then I have a Python questions so that I can answer some of the questions. So you can do some other, right? But you can do this more questions. For example, some of the questions, some others, right? Other ones, maybe. And then if you want to see the video lecture, click this, then it goes to some of the videos, click this, then it goes to the videos. Actually, that is my lecture. Okay, so we stop this and go back, back. Very similar to that, but to this string and format, similar to that, and then it goes to the web server and some of the object-oriented the lecture may be possible here on this web-based learning. Okay, go back and back and back. All right. Basically, this is what we have been doing. I think I have about 10 minutes to answer to your questions if you